Okay, section 1, notation and representation. Right. Oh. Right, try again. Given vector A equals 3i plus 4j, and vector B equals I take 2j, find vector A plus 2 vector B. Alright, so finding the I component first. That would be 5. And then the j component, 0. And so their sum is 5i. So 5i is vector A plus 2 vector B if vector A is 3i plus 4j and vector B is I take 2j. For a triangle ABC, A to B is vector A, B to C is vector C. Express C to A. Alright, that would be negative vector B minus vector A. Hello. Next. Given vector A is 5i plus 2j and vector B is 3i plus 7j, find vector B minus vector A. Minus 2i minus 5j. So minus 2i minus 5j is vector B minus vector A, when vector A is... Okay, so today it's going to be harder, I guess. So try again. Okay, vector A is 5i plus 2j, vector B is 3i plus 7j. Calculate vector B, take vector A. Okay, that's 2i minus 5j. No, that's not right. Do it again. Minus 3i plus 5j. So minus 3i plus 5j is vector b take vector a when vector a is 5i plus 2j and vector b is 3i plus 7j. Find the value of k when 4i plus kj is parallel to 2i minus 5j. The answer is minus 10. K is minus 10. So when k is minus 10, 4i plus kj is parallel to 2i minus 5j. Given vector b is 3i minus j and vector q is I plus 5j, find 2 vector p take vector q. Five I plus 3j. So 5i plus 3j is 2 vector p take vector q when vector p is 3i take j, and vector q is I plus 5j. Okay, next up, magnitude and direction. Find the magnitude of 5i take 12j. Applying the Pythagorean theorem to the components, 5 squared plus the square of negative 12 all square rooted, we obtain 13 as the answer. So 13 is the magnitude of 5i take 12j. Find the unit vector in the direction of 3i plus 4j. 3i plus 4j has a magnitude of 5, and thus the unit vector in that direction is 0.6i plus 0.8j. So 0.6i plus 0.8j is the unit vector in the direction of the vector 3i plus 4j. Find the exact magnitude of 6i minus 6j. The answer is 6 root 2. Six root 2 is the exact magnitude of 6i minus 6j. Find the angle root 3i plus j makes with the positive x-axis. So we just do trigonometry on the components of the implied right triangle there. The adjacent is root 3. The opposite is 1. So we use tan of theta equals the opposite over the adjacent. So tan of theta equals 1 over root 3. And thus theta is 30 degrees. So 30 degrees is the angle that root 3i plus j makes with the positive x-axis. Given vector A is 3i plus 4j, and the magnitude of lambda vector A is 20, and lambda is greater than 0, find lambda. The magnitude of vector A is 5, and thus lambda is 4. So 4 is the size of lambda when the magnitude of lambda times vector A is 20, and when vector A is 3i plus 4j. Oh, and by the way, when lambda is greater than 0. Okay. Third section is position vectors. Points A and B have coordinates 1, 2 and 4, 6 respectively. Find the position vector A to B, as in the instruction kit on how you get from point A to point B. Well, to go from 1, 2 to 4, 6, we follow the instructions 3i plus 4j. So 3i plus 4j is the position vector A to B when point A is 1, 2 and point B is 4, 6. For those same points, find the magnitude of the direction vector A to B. As the vector itself is 3i plus 4j, the magnitude is famously 5. Points A and B have coordinates 2, -1 and 6, 7 respectively. Find the direction vector. Oh man. Let me try that again. Okay, points A and B have coordinates 2, -1 and 6, 7 respectively. Find the direction vector of the midpoint of the line segment AB. Okay. What you do is you just find out how to get from vector A to vector B. Or, in other words, actually, you just simply find out the midpoint of the pair of points. So if the pair of points are 2, -1 and 6, 7, then the answer is 4, 4, and thus the position vector is 4i plus 4j. Given O to A is 3i plus j, and O to B is 7i plus 9j, find the magnitude of A to B. Okay, well, we need to find A to B first. So I want to say how to formally do this. A to B would be A to O plus O to B, and A to O would be minus 3i minus j, and O to B would be 7i plus 9j, and thus A to B would be 4i plus 8j, and the magnitude of that would be 4 squared at 8 squared, all square rooted, which is root 80, which is 4 root 5. So 4 root 5 is the magnitude of A to B when O to A is 3i plus j, and O to B is 7i plus 9j. Okay. Try again. Point P lies on the line segment A to B. And segment AP to PB is in a ratio 1 to 2. And point A is at 1, 2. And point B is at 7, 11. So find the position vector of point P. Okay. What we need to do is we need to find out the direction vector A to B. As in, how to get from point A to point B. Now, A is at 1, 2, and B is at 7, 11. So the direction vector A to B is 6i plus 9j. Then divide that by 3. So we get 2i plus 3j. And that will be the smaller part of the ratio. 2i plus 3j. And so now we add that on to point A. Or rather, we add that direction vector to the position vector of point A, which is 2i plus, which is 1i, which is I plus 2j. So it would be I plus 2j plus 2i plus 3j, resulting in 3i plus 5j. So 3i plus 5j is the position vector of P. There are shortcuts that can be taken, but I want to do this rigorously. So to be clear, 3i plus 5j is the position vector of P. 3i plus 5j is the position vector of point P when point P lies on the line segment AB, and we're told AP to PB exists in a ratio of 1 to 2, and we're also told the coordinates of point A and point B, and they are namely 1, 2 and 7, 11. Right. Okay, so now we're going to solve geometric problems with vectors. In a parallelogram OABC, OA is vector A, OC is vector C. Express OB in terms of vector A and vector C. Alright, that would simply be A plus B. And the reason why is because AB and OC are parallel, and thus OA is vector C, rather AB is vector C and OC is vector C. So we say A plus B. Vector A and vector A plus vector B. In the triangle OAB, OA is vector A and OB is vector B, and M is the midpoint of B and C. Express, darn it. Okay. In the triangle OAB, OA is vector A, OC, in the triangle OAB, OA is vector A, OB is vector B, M is the midpoint of A and B. Express Okay, we've got to be really clear here. In the triangle OAB, right, we need to decide what we're actually going to say about this. Are we going to say direction vector OA? No, that's far too long. We're just going to simply say O to A. And I don't like calling the vectors vector beforehand, but you have to deal with it because they use the same letter for everything. Alright, just different notation. Alright, so let's do it then. So in the triangle OAB, O to A is vector A, O to B is vector B, M is the midpoint of A and B. Express O to M in terms of vector A and vector B. Okay, so the answer is simply half A plus half B. Half vector A plus half vector B. So annoying that I have to say that, but I guess I just have to. Right. Okay. Determine whether the points A, how am I going to say this? Let A, B, and C be 3 points. A is 1, 2, B is 3, 6, C is 6, 12. Determine whether or not they're collinear. If they're collinear, then A to B and B to C must be parallel, first of all. Alright, so A to B is 2i plus 4j. B to C is 3i plus 6j. And 2i plus 4j and 3i plus 6j are indeed parallel. So they are collinear. Yes, that's true. 1, 2, 3, 6, and 6, 12 are collinear. In triangle OAB, O to A is vector A, O to B is vector B. In triangle OAB, O to A is vector A, O to B is vector B. Come on, say it again. In triangle OAB, O to A is vector A, O to B is vector B. One more time. In triangle OAB, O to A is vector A, O to B is vector B. And M is the midpoint of OA. In triangle OAB, OA is vector A, OB is vector B, M is the midpoint of OA. Express M to B in terms of vector A and vector B. Well, half O to A rather O to M plus M to B. No, totally wrong. Fine. M to B is M to O plus O to B. Now we have O to B, but do we have M to O? Yes, we do. It's negative a half vector A. So minus a half vector A plus vector B. So minus a half vector A plus vector B is M to B in the triangle OAB, where O to A is vector A and O to B is vector B, and M is the midpoint of OA. Okay? All right. given O to A is 2i take j, and A to... given O to A is 4i take j, and A to B is try again. Given O to A is 4i minus j, and A to B again. Given O to A is 4i minus j, A to B is 2i plus 5j. Find the magnitude of O to B. Okay. So O to B will be O to A plus A to B. So we do 2i minus j, no, 4i minus j plus 2i plus 5j to get 6i plus 4j. And then find the magnitude of that. So that'll be 36 at 16, which is 52. Square rooted is 2 root 13. Okay, so you know, this is taking quite some time, so just gonna have to leave that section just for a little bit. We're gonna do differentiation now. It's unbelievably sweltering right now. Okay. You know what? Let's just go for a walk, because this is not productive to do it at this stage.